Okay, very good. We've got the after lunch crowd. Very good. So before we start, I just want to know who's in the room. So raise your hand if you are a Solidity developer. Okay, raise your hand if you work in security in some way, smart contract security. Okay, raise your hand if you want to work in smart contract security and you're here to learn. Okay, you're all already experts, got it. Except for this guy, he needs help. Okay, so yes, I'm Joseph. Today we're going to talk about 4626, which is one of our favorite Ethereum standards. It's a token standard. It's also known as the Vault standard, and it was. We're going to go into the history of that. We're going to have a little overview. And then we're going to talk about an attack vector called inflation attacks and learn all about that. So first off, I'm Joseph. Thank you for the intro earlier. I won't spend too much time shilling my own stuff, but I think 4626 is very cool, and so that's why I wanted to give a talk about it. I use it a lot, and it's also very good for experimenting because there's lots of 4626 support in all of other protocols that you want to connect to. So we're going to talk about why it's cool, then learn about that attack vector, and then how to prevent it so that you can become a security auditor and get bug bounties on billion-dollar protocols by the end of this talk, okay? Do you believe me? Okay, good. Let's see. Now I lost my slide. Oh, next one. There we go. So, number one, vaults are cool. So, who has ever deposited in a vault? Any type of vault? Everybody who's paying attention. Great. So, vaults are very good because you can put things into them, and your assets might become more valuable, or you get some utility out of it. And there's only so many different things that we really do with our tokens. We sell them, we hold them, we buy more. But one of the other things is we put them in vaults, and it's either a staking vault or a yield aggregation vault or a savings account vault where you put in dollars and it earns savings yield, right? So there's all these different types of experiences, and there's no particular one thing that ERC-4626 was built for, and there's no one particular use case. It's anytime people put money in and they want to get it back later with some additional benefit, this is a way to do that. So lots of companies have made vaults. Yearn, Alchemix, Beefy, they have different types of lending and different types of yield-bearing vaults where you can deposit stablecoins or deposit ETH. And they all kind of came together and said, hey, we want all of our vaults to work together. We want everyone to have one standardized interface for the things that vaults do. So if you have a vault, what are some of the actions that there are on a vault? Somebody? Yes. Deposit. What else? Redeem. Yeah. What else could someone do on a vault? Maybe liquidate, right? Unstake, stake, stuff like that. So if we have a common interface that everybody uses, then we can build really cool experiences like Bunny has done. And Bunny lets you deposit LP tokens into Uniswap. So you can put tokens in, and you can rehypothecate that liquidity into any 4626 vault. So any Yearn vault, any Gearbox or Alchemix or Beefy vault, you can move tokens around really, really easily. And because everything's standardized, it's safer. And it's much, much cheaper to build because we can build this ourselves in like 2 minutes. So hooray, we did it. We solved vaults in crypto, right? Well, not quite. There's some interesting things that we have to know about a vault. So anytime you put one token into a vault, you should get a receipt for one token, right? But if the value of the one that I have deposited is going up, right? Let's say I've deposited into some kind of yield-bearing vault, and the value of it doubles. Now, when I put 1 in, I only get 0.5 back, right? Because the value has doubled, so the exchange rate changes over time. So the exchange rate of tokens going into the vault and how many tokens you can redeem it for changes over time. So let's see, receipt. There we go. All right, so we've got different lines here, and each line is a particular redemption rate. So we've got a rate of put in 1, get 0.5 out. Put in 1, get 1 out. Put in 1, get 2 out, right? And those are the different lines, right? It's basically y equals x or y equals 2x, right? So we can kind of plot that on a graph to make it a lot more visual. And we've got a problem already, because what happens if you have 0.5 of an asset? What happens if you have 0.5 of a token in Ethereum land? Who knows? Solidity developers. Half the crowd already raised their hand and said they were a Solidity developer. Yes. Uh-oh, it rounds down. That's right. So if you ever have 0.5 of something, it's always going to round down in favor of the vault value and rug the user. So raise your hand if you love rugging your users. Get this man out of here. Security. All right, so we don't love rugging our users. We hate rugging our users. We love our users. We don't want them to get rugged. So anytime someone deposits 1 and we give them 0.5, that rounds down to 0. So they're going to put in 1 token and they're going to get 0 tokens out. That's very sad. So we don't like that. Another way we can plot that same exact graph, I'm going to go back. So we have these 3 lines. These are the top 3 lines, right? The blue, the purple, the blue, the green. Those are the same exact lines, just plotted on base 10 instead of linearly, right? So if we plot this is the exchange rate of different vaults, right? Or of the same vault at different values. So if I have a place on this curve, right? I'm exchanging 10 to the 0, that's 1, right? Token, and I get 1 token. So what happens if that changes, right? It's going to change over time as my tokens become more valuable. And that means there's another way it could change. What if somebody donates to the vault, right? And they send 10 cents or they send $1 themselves directly to the vault. Then the next person who deposits is going to get a worse rate, right? Because they're not going to get the 1 for 1. The value in the vault is now slightly more. So if that is 1 for 1, maybe it's 1.1 for 1, right? Or 1.5 even, or 10 to 1, right? So this inflation attack exists where essentially the graph slides over to the right because the value inside of it has been increased, and we didn't prepare for that. So we have this super awesome standard 4626, and everybody should use it for your hackathon projects. If you want to become an auditor, you're going to run into this all the time because it's one of the most used smart contract interfaces now. But just because that code has been audited and it's a standard and it's safe and people like it, doesn't mean that it's safe no matter what forever, right? So this is a very known issue, this inflation attack, where the value inside the vault has been inflated and moved to the right. And now that rate of redemption is not as good for the user. And depending on what those numbers are, the user could lose all of their money, right? If the rate brings them down to a decimal and it rounds to 0. So every time we make a new vault, we have to simulate not just what is happening when everything is going well, but what happens if people donate to the vault, and what happens what happens if somebody front runs our initial deposit into the vault, right? So we got to be really careful of these roundings, and the inflation attack is real and can happen to you. So let's look at another example here. If you deposit 500 assets on this curve, that's kind of how much you get back, right? So depending on where you are or which rate of redemption you're on, right, which graph you're on, you could get 500 assets back, or you could get 0 because you got slightly less than 1. So it depends on where this graph is, and if you move the slider to the right, if you move where the redemption rate is to the right. The what? There's a laser button. Oh, there's a laser. Okay, cool. Boom. Whoa. I'll try that. We've moved the graph to the right, but now the place that they redeem it is down here. And if that is less than 1, then the user's totally rugged. They've lost all their money because they got $0 left because of the rounding. So inflation, rounding, that could happen. All right, what's this one? I don't know. That's the same. Okay, so the solution. What's the solution? I meant to ask everybody to come up with their own solution, but I already skipped it, so we'll just go on to this. So, solution, limit the deposits. You can write your contract that says you're not allowed to deposit right at the same time that somebody else has just deposited. So if an attacker deposits to try to suck up the yield and earn all those fees and earn the normal user's deposit by attacking them, you can say, hey, you're only allowed to deposit 10 blocks after, or you're only allowed to deposit a certain amount of the percentage of the total vault value, right? So we can do things that don't allow the attacker to use flash loans to attack our vault and say, okay, you have to wait until an unlock period. Or we can check for rounding, right? We can just do the math ourselves and say, hey, did any rounding happen? And if a maximum amount of slippage has been detected, then just revert and don't let the user deposit and don't let our users get wrecked. Or you could seed all the vaults yourself and have initial liquidity in all of them and make sure that users are not allowed to deposit until there's a certain amount of liquidity that you already control, and then make it more centralized, but that's not as fun. So vaults are really good. They let us create money Legos. So I got this little money Lego over here, right? We've got Ethereum, Yearn, Alchemix, Compound. They all use these vaults. They all use 4626 vaults. Not Ethereum directly, but Yearn and Alchemix and Compound do. So we want them all to play together, and people are going to give you contracts to audit or ask you to integrate with whatever you are building and connect to our vault, or get your users to deposit in our vault, or our vault is going to interact with your protocol in some way. They're going to ask you that, and this, because it's standardized, it's going to feel like everything is going to be just perfect all the time because we love ERC standards. But actually, you must be very careful because inflation attacks are real. And if you wanted to be an auditor, somebody said that they were trying to become an auditor. This is a very common issue that you can make lots of money by pointing out to people. So that's pretty much it. I'm Joseph. Thank you for coming. I hope that this has been a little bit valuable for you and that you will never, ever be inflation attacked. Thank you.
Okay, big applause. We can start the QA session. So if you have a question, please raise your hand.
Great, and we're well ahead schedule. So if you have any questions that's not specific about this talk or vaults in general, you just want to know what my favorite food is, that is totally cool too. Yes?
So what is your favorite solution for solving inflation attack?
My favorite solution is adding, oh, where did I go? There we go, is this one, I love this laser pointer. This is great. Is check for rounding and adding a slippage parameter that is not enforced by the vault, but rather completely up to the user. So like you go on Uniswap, you get to choose what slippage you want, right? If you're making a trade, you should have complete freedom to wreck yourself with 100% slippage and lose all your money, or you have a default value of like 0.1, right? And personally, I believe in autonomy and freedom, and everyone should be able to have the freedom to wreck themselves if they want. So you can have a slippage parameter that can be set by the user and give them a healthy default value and revert if the actual slippage is over that percentage. Does that answer your question?
Yeah, but this breaks the interface, right?
But it breaks the interest?
Interface, standard
Yes.
interface.
Yes, it might break the interface. It's possible. Yeah. So you can also, you could maintain the same interface of the contracts and have a separate variable that the user sets outside, and if it's not set, use the default one of 0.1% or something like that. How's that? Because then it doesn't break the interface, right?
Really nice, man.
Yeah. Okay.
Thank you.
Any other questions? Thank you for that. That was a good question. Anything else? Andre, what's your question? What's the best contract in the world?
Country.
Country? Serbia is very nice. I'm having a great time here. So thanks for all the Serbians who have welcomed me and been very polite. Any other serious question? Any other silly question? Okay. Thanks for coming. I really appreciate seeing so many people and listening to me. I appreciate you all. And please message me if you ever need a security audit or you need help with anything related to this or you just want to talk. So thanks.
Okay, huge applause. Thank you. Thank you.